This video is about the power theorems using circles. So there are three power theorems that use different types of segments of a circle. So the first one is a chord, then a secant, and then a secant tangent. So let's go through each of these power theorems. So in a chord, if two chords intersect in the interior of a circle, then the products of their lengths of the segments of the chords are equal. So if we have the chord AC and BD, those have both been broken into pieces because of the intersection. So if we say that AE is 5, EC is 4, BD is 10, and ED is 2, when we multiply the pieces from each chord together, they're going to multiply to the same number. So in this case, both of them multiply to 20. This is important to help us find a variable. So let's use this idea to solve for x, or the other variable listed. So in number 1 to solve for x, 4 and 6 come from the same chord, so they get multiplied together. 3 and x come from the other chord, so they get multiplied together. So we get 24 equals 3x. We can divide by 3 on both sides, so x is 8. In number 2, when I multiply, the one chord has the pieces 4 and 2 that multiply together. The other one has 5 and y. So we get 8 equals 5y. When we divide by 5, we get 8/5. Now remember that sometimes it's not always going to be a whole number, so fractions are fine. Just leave it as a fraction answer. Number 3, we have k on two parts of the chord, which means that they're congruent. So we're still going to multiply k times k equals 4 times 9, and we get k squared equals 36. The square root of 36 is 6. In number 4, the pieces that we have are z and z, which means this chord was bisected. Z times z equals, and the pieces are 8 times 6. So we get z squared equals 48. That's not a perfect square, so we get the square root of 48, and we have to break that down. So if I make a factor tree, I know two numbers that multiply are 6 and 8. Two numbers that multiply to 6 are 3 and 2. Two numbers that multiply to 8 are 2 and 4, and two numbers that multiply to 4 are 2 and 2. So I have a pair of 2 and a pair of 2's, so we would get z equals 4 root 3. Number 5, in circle P, CE is 4, CD is 16. So if the whole length is 16 and part of it's 4, we can call this side 16 minus 4, which would be 12. Then we have that AB is 14. If we want to find EB, we're going to call EBX. So if the whole length is 14, we got to take away that x part, so the other part of the line is going to be 14 minus x. So when I multiply my pieces together, I get 4 times 12 equals 14 minus x times x. So when I distribute, I get 48 equals 14x minus x squared. Remember, in order to factor, we need the x squared to be positive. So we're going to move to the side with 48 so that x squared gets positive. So this becomes x squared minus 14x plus 48 equals 0. So two numbers that multiply to 48 and add to negative 14 are negative 6 and negative 8. When we switch our sign, then we get x equals 8 and x equals 6. Both of those solutions work. So then when we're trying to find AE, there's two cases that's going to happen. If EB is equal to 6, and they have to add to 14 together, because remember, AB is 14, then AE is going to be 8. If EB is 8, then AE would have to be 6. And we don't know which is true because of how the picture is drawn, and we can't always assume looking at the picture, so we're going to say both cases for EA. Secant tangent. So a secant tangent's a little different. In a secant tangent, they're going to intersect from the same point on the outside of the circle. So when we are finding the secant tangent, it's the whole side times the outside equals the whole segment times the outside. So if we are labeling for an example, let's say that this is 4 and this is 6, and we'll say that this is 5 and this part is 3. So on the top, the whole length is 10. So if the whole length is 10 and the outside is 4, that's 40. In the other part, we have the outside is 5 and the whole length when I add it together is 8. So 8 times 5, they equal the same number, 40. So let's use this idea to solve for our variables. So in number 7, the top length over here, we're going to add those together. That gets us 10 plus x. And the other secant, 4 plus 8 gets us 12. So we're going to use the whole length and the outside of each secant. So on the top secant, the outside, the whole thing is 10 plus x times the outside, which is x. The other secant, the whole side is 12 and the outside is 8. So when we multiply that together, we get 10x plus x squared equals 96. We can move 96 to the x squared side. So we need two numbers that multiply to negative 96 and add to 10. So we have x plus 16 and x minus 6 equals 0. When we switch our signs, we get that x equal to negative 16 and x equal to 6. Negative 16 does not work because we can't have a negative side length. So let's try another example. In number 8, the whole length of the top secant is 10, and the whole length of the bottom secant would be 5 plus y. So again, we're going to do the whole times the outside for both secants. So we get 10 times 4 equals 5 plus y times 5. So we get 40 equals 25 plus 5y. We can subtract 25 from both sides. We get 15 equals 5y. When we divide by 5, y equals 3. In number 9, the top secant, when we add those pieces together, 11 plus 4 is 15. And in the bottom, when we add them together, 6 plus k gets us 6k. So remember, we're going to do the whole secant times the outside. So we have 15 times 4 equals 6 times 6 plus k. So we get 60 equals 36 plus 6k. We can subtract 36 from both sides to get 24. And when we divide, k is 4. In number 10, the whole secant on the top is 15 because we have 8 plus 7. And on the bottom, the whole secant is q plus 2. So remember, again, we're using the whole times the outside. So we have 15 times 8 equals q plus 2 times q. So 15 times 8 is 120 equals q squared plus 2q. So because there's a squared term, this is a factoring, so we're going to move 120 to the other side. So q squared plus 2q minus 120. So two numbers that multiply to negative 120 and add to 2, we would have k plus 12, q plus 12 and q minus 10, which means that q is equal to negative 12 or 10. And again, our negative number won't work because we can't have a negative side length. So let's look at an example where we have a picture drawn. Ignore the BP for now because that's going to throw you off a little bit. So we have two secants. We have AB and we have AE. It tells us that AC is 3, BC is 5, AD is 2. And in the first part A, it says to find ED. So we're going to call EDX. So in the top, we have 8 and the outside is 3. And in the bottom, we have x plus 2 and the outside is 2. So when I multiply, I have 8 times 3 equals 2 times x plus 2. We get 24 equals 2x plus 4. We can subtract 4 from both sides and divide, so x equals 10. If we know x is 10, ED is a diameter because it's a chord that's going through the center of the circle. So if we're looking for PD, these are both radii, which means it bisects the diameter into 5 and 5. PB is also a radius because it goes from the center to the circle, so that's also going to have a length of 5. Because remember that all radii in a circle are congruent. The last power theorem is tangent secant. So in a tangent secant, we're still going to use the secant part like we were, and the tangent is going to be squared. So for example, if AB, which is the tangent because it only touches the circle once, is 6, and we have the sides 3 and 9, the whole secant is 12. So we have 12 times 3 equals 6 squared, and that's true because 36 equals 36. So let's try finding our variable. So number 12, the tangent is 10, so we're going to do 10 squared equals, on the secant, the outside is x plus 5 for the whole thing. The outside is 5. So we have x plus 5 times 5. So this gets us 100 equals 5x plus 25. We can subtract 25 from both sides and divide by 5. So we get that x is 15. In number 13, our tangent is x, so we're going to say x squared equals, the entire length of the secant is 16 because 4 plus 12 is 16, and the outside is 4. So we have 16 times 4, which gets us x squared equals 64. To get x, we'll take the square root and get that x is 8. In number 14, our tangent is 4 root 5. So we're going to square that. And then in our tangent, our secant, we have x plus 11 is the whole thing, and x is the outside. So we have x plus 11 times x. So if we put 4 root 5 in the calculator, make sure we're using parentheses, we get that's 80 equals x squared plus 11x. So we can subtract 80 from both sides. So we get x squared plus 11x minus 80. We need two numbers that multiply to 80 and add to 11. So those numbers are 16 and negative 5. So when we switch our signs, we get x is negative 16, which won't work, and x is 5. Let's try one more example. So in this example, our tangent is x squared, so is x, so we're going to square that. The secant, the whole length is 12, 9 plus 3, and the outside is 3. So we have x squared equals 12 times 3, which is 36, and we take the square root, we get x is 6.